An axis-aligned bounding box is a 3D box with volume. It is defined as having width, height, depth, a center position, and minimum and maximum extents. Now, axis-aligned is just a fancy way of saying it's not rotated. So it's a box that isn't rotated, it's aligned to the axis of the world, and because of that, it's kind of a simplified shape. We can make some assumptions because it's not rotated, and that makes some of the math can be performed very, very efficiently because of those assumptions. So the axis-aligned bounding box is defined in the AABB class, and it has the following members. It has a vec3 for the minimum extent, that's the minimum point. It has a vec3 for the maximum extent, that's the maximum point on each axis. It stores the center, which is halfway in between the minimum and the maximum. It stores the size, which is the maximum minus the minimum. And it also stores the radius, which is the distance from the center to one of the corners. Now, to define a axis-aligned bounding box, we use this constructor, and the first three arguments are the minimum extent, and the next three arguments are the maximum extent. So when we construct the bounding box this way, it will automatically calculate the center, the size, and the radius from that definition. So this bounding box has a minimum extent of -2, -1, -1. So that means this point here is -2 on the x-axis, -1 on the y-axis, and -1 on the z-axis. And then its maximum extent, this point up here, is 2, 1, 1. That means its width is going to be +2 minus -2. So its width is going to be 4. Its height and depth is going to be 2 because it's going between -1 and +1 on both the y and z axes. Let's just copy this code and we'll paste it right into main.lua in a new Lua project, and let's see what it says. So the minimum extent for our bounding box is -2, -1, -1, just like we specified. The maximum extent is 2, 1, 1. The center is 0, 0, 0, which makes sense. And then the size is going to be 4, 2, 2. So it's 4 wide and 2 high and 2 deep. And then the radius is 2.44, really long number. So this is your axis-aligned bounding box. Now, why would we want one of these? You can use these for a variety of intersection tests. We can tell if an axis-aligned bounding box intersects a point. We can test the intersection between two of these things. We can test the intersection of a box and a line in 3D space. And we can also test the intersection between a bounding box and a plane. Now we can modify our bounding box at any time. Let me copy this example here. But if we do, we just need to call this update method again. So here I'm going to start with a bounding box that is between -1 and +1. So it's going to be 2 wide, 2 tall, 2 deep. The center should be 0, 0, 0, which is the origin. And then I'm going to change the minimum extent on the x-axis to 99. And I'm going to change the maximum extent on the axis to 101. So that would put the center right between 99 and 101, which would be 100. However, until I call this update function, it's not going to update the center and the size and the radius. So if we first change this and then print the center out, it will still print 0, 0, 0. And then after we call update, it will recalculate the size, the center, and the radius given the minimum and the maximum extents. So it says 0, 0, 0. That's how it is when we start, when we first define the bounding box. And then it says 0, 0, 0 again, which is after we change these extents on the x-axis, but we haven't updated it yet. And then after we call update, then it will print out, it will recalculate the center, and it will print the correct center, which is 100, 0, 0. So the center and the size and the radius are always calculated from the minimum and the maximum extents. You can change the minimum and the maximum extents and get a new center, size, and radius, but you can't manually change the center and calculate. If you change the center, it'll just recalculate the center. If you call update, it won't recalculate the minimum and the maximum extents. Okay. Now, the engine uses these extensively internally for a lot of routines. You might or you might not need to actually use these in your own code, but it's another tool in your toolbox. And it's important to know that you have this available. So every entity that is a 3D object in your world, in LeadWorks, every entity has 3 bounding boxes that you can retrieve at any time with this entity get bounds method. You can get the local bounding box, and this encloses the entity and it's defined in its own local coordinate system. You can get the global bounding box, and this encloses the entire entity in global space. And you can get the recursive bounding box. This encloses the entity and any child entities that it has in global space. So in this example, let's see. We're going to use axis aligned bounding boxes from 2 entities to see if they overlap. So let's paste that example in. Let's take a look at what's going on here. First, we're creating one box. This is box 1. And we're going to position it at -1, 0, 0. So we're moving it 1 unit to the left. And then we're creating box 2, and we're going to move it 1 unit to the right. And then we have this set up so that when we use the arrow keys, then box 2 will move around on the screen. Looks like it'll move left, right, up, and down. Okay. And then we're getting 2 bounding boxes. This is bounds 1 and bounds 2. These are both AABBs. These are both axis-aligned bounding boxes. And they're retrieved from these 2 entities using the getBounds method. And I'm specifying that I want the bounding box in global space, and I'm going to compare these. I'm going to do that with this bounds 1 intersects AABB bounds 2, and then if they intersect, I'll set their color to red. If they don't intersect, then I will set their color to green. So they're green, they're not intersecting. I can move it around and nothing happens. But when they intersect, there we go. Now this is only these bounding boxes are axis aligned, so they're not rotated. So let's try rotating one of these actually. We'll just say box set rotation 0, 0, 45. So we're going to rotate this 45 degrees around the z-axis, which will make it tilt on the screen. And you can see this isn't a perfect intersection test. It's only an approximation because the bounding box of this rotated object, it's still axis aligned. So even though the box shape is tilted, the bounding box is actually like right here. And that's why when we enter that volume, even though the two meshes are not intersecting, their bounding boxes are. This one's got a little bit bigger bounding box because it's tilted. And so the box just stretches out to fully encompass all the corners of the mesh. Here's another example. If we just change these into spheres, then you can see the same principle. Let's see. We'll create two spheres instead of two boxes. And it doesn't really matter, but I'll just comment out this rotation command. And we'll run this. Same idea. It's only a rough test. And that's what makes axis-aligned bounding boxes so fast, is because it's only a rough test. Very often, a test of an intersection test or something else is used with axis-aligned bounding boxes before you progress to a more expensive and complicated test that might be accurate. This is just a good way of discarding objects that aren't even close to each other. So that's pretty much all there is to know about axis-aligned bounding boxes. They're pretty simple, but it's just another tool in your toolbox that you can use whenever you run into a problem that you think that this could solve when you're developing your games.